Okay, so for lab 21, the capacitance lab, here is the circuit that I made, and then the battery pack is attached to the other experiment, but let's just pretend it's there. And here is my table that I made for it that I will upload later. The first post-lab question asks, how did the behavior of the LED differ when you added this second capacitor in part 1? And I said the LED lit up a lot faster when I added the second capacitor. And then the third question asks, how did the behavior of the LED differ when you added the second capacitor in part 2? And I said the LED tended to light up a bit slower in that situation when the second capacitor was added. Question 4 asks, after adding the 470, I think that's volt, I'm not quite sure, capacitor in part 2, are the capacitors in series or in parallel? Use data to support your answer. And I said the capacitors were parallel, and then I did the little equation, which you'll see when I upload to Foxtail. And then for lab 22, which was the resistivity in Ohm's law lab, let's see what the post-lab questions ask. Here are my tables, by the way, which will be uploaded. And then here's the whole setup for that. And the first post-up question asks, find the resistance in each case of Plato using Ohm's law. Yeah, so I completed table 7 and table 5 and did that math. And then question 2 says, make a plot of resistance R versus length L and resistance versus area A. So here are the two graphs I got from that. So the one, 3 says, what is the relationship between R and L? So as R, or as L increased, the length increased, the resistance tended to increase until it reached a certain point. I think it was like 0.20, or no, 0.18. And then it started to decline, which I thought was interesting. And then 4 says, what is the relationship between R and A? And I said that it was pretty much consistent except for the first 2. But once the area got to like 0.023, it just kept consistent. And then question 5 says, determine the resistivity of the Plato from the slope of the graph. And I just said that Plato resists more as the length increases and resists kind of consistently as the area increases with the Plato. And then question 6 says, does the resistivity of Plato change when the length or area changes? And I said that the Plato basically conducts electricity and provides resistance depending on how long and how thick it is. So I found that basically larger diameters and shorter lengths provided a greater resistance, created a greater percent difference, and then I found the percent difference between those was 1.9%. Yeah, that's all.